I'm Théo. I'm a French student, and I'm here today to show you how we can study the flow behind an object created by CAD. We do this application with the software Fusion 360 and OpenFOAM. In our example, we will study an airfoil. This study is divided in three parts: conception of the geometry with the CAD software, meshing on Salome, and simulation with the EcoFoam solver. To begin, we have to make the geometry. I have chosen the Autodesk Software Fusion 360. This part of conception is on Windows, and the others will be on Linux. The link to download the software is in the description. It's free for students, so let's go. After downloading and installing Fusion 360, we can add the plugin Airfoil DATA. So click on Tools and App Store. On the website, search Airfoil. Download it and install it by just click on the download file. Then we have to select our NACA and recover data of the airfoil. We can choose one of the suggestions, but you can create your NACA on the generator. So we select profile, and you have to copy the data from the page and paste it on a notepad. So copy all of the data, open a notepad, paste it, and save the file as a dat file. Name the file as you want. In our case, we put the name of the NACA, point dat. Now return on Fusion 360, and we have to create a two-dimension plane. So select the plan, OK, and now we are going to launch the plugin Airfoil DATA to Spline. So go on Tools, Add-in, Scripts, and Add-ins. We can see our script, so select it and run it. Select the plan. Okay. And now we have to load the data from the file. So select the file when you save data and OK. You can see that a sketch appears, and we can notice that the sketch is not closed. So delete one point and join the last with the point to close the geometry. So the sketch is closed. Now we have to unclose the profile. So we will draw a rectangle with specific dimensions. To have a good view of the flow, we make a box 3 times the length of the profile ahead, 7 times behind, and 5 times the thickness of the airfoil in 8 on both sides. So I accept the clip, and we obtain finally the box of your application. So now we have to extrude the box in 10 millimeter and extrude the profile in 10 millimeter to make a hole in the box. So we have our geometry. It's ready, so we can export it on step file with the name of our NACA. Now we have to go on Linux for the end of the study. On Linux, open your file and copy it to put in your folder. So copy your file and you have to download an Ecofoam folder from the description and put it. So in my case, I have the Ecofoam. So I passed the folder. I copy my Ecofoam folder for the tutorial. So I rename my folder and I put my file in the tutorial folder. So now we have to open a terminal and use the command Salome to open the software. Okay, on Salome, select the Geometry tab and import your step geometry in File, Import, Step. Choose your file, open. So your geometry is on Salome. You can delete still solid, and your geometry is import. So now we have to create group to define the different elements of the geometry. So we create group of face. So in the first part we create the inlets, the outlets. It's the same operation for all parts. Choose the face, click on add, and rename your face. We have after lateral rights and lateral lefts. Select your face, apply. After we have top and bottom in the same group. Apply. And finally we have the airfoil. So select the airfoil and add it, apply, and we can close. So we have to check that all groups are well defined. So we have our geometry and we have our groups. So inlets, outlets, lateral rights, lateral lefts, top bottom, and the airfoil. So it's okay. So now we have to choose the mesh tab for meshing. We can rename our geometry and create mesh. This mesh is created from the geometry, and we have to don't choose create all groups on geometry because we do this after. So in 3 dimension, select the algorithm extrusion 3D, and in 1 dimension, select wire discretization with a number of segments of 1. Apply and close. So your first mesh is ready. You have to create a submesh for the 2-dimension mesh. So from the lateral right or left as you want, select the algorithm NetGen and configure the parameters. So in the first part we keep initial parameters, apply and close, and we can compute our mesh. This is very quick, and we have an error. So we will edit 2D parameters to decrease the size of the mesh, and it can be interesting to refine our mesh to have best results. So go on submesh, edit submesh, and edit NetGen 2D parameters. So we refine our mesh. Okay, apply and close, and we have to compute. Now the mesh is okay. We have the explanation of the mesh, and we can see that this mesh is on 2 dimension. So our is ready. We have a last part in Salome. We have to create group from geometry. So go on mesh, create groups from geometry. So submesh. So go on submesh, sorry. Go on submesh, create groups from geometry. Select all groups you created before and put it on our mesh. Groups of nodes and groups of faces are created. So now our mesh is ready for right click and export as UNV file. Name your file as you want. In our case, we select the number of our NACA. So now we have the UNV file in our folder. So before closing Salome, you can save your projects as with the same name. So now close Salome, and we are in the last part of the study. So open a terminal and use the command ideas UNV to form. Use the name of your file, and now you have the mesh converts in OpenFOAM. So go on polymesh boundary, and you have to configure our group. So we have inlet, outlet, and as patch, lateral right and lateral left as empty, top bottom as symmetry, and airfoil is a wall. So save the file and go back on 0p, and we have to edit the name of the part. So sides is replaced by top bot, front by lateral right, lateral left, sorry, and back by lateral right. Finally, wall seal is airfoil, and we can have to do the same thing with the U file. So inlet outlet it's okay. Top bots, front is replaced by lateral lefts and back by lateral left, right. We'll seal airfoil. So now we are ready for the calcul. So go and control dict and edit your parameters. So we just put 0.1 at the end time, and we will keep the initial parameters. So save and return on the terminal, and we can launch the EcoFoam solver. So I accelerate the calculation because it's quite long. So we can see that one folder is created by each part of the calculation. So I select 0.1, so we have to generate a long number. So it's okay. So we have a calculation of 49 seconds. So if we open one folder, we have an indication about the time and all data. So we can now go on the terminal and launch ParaView with the paraform command. The software is launching. Click on apply, and now we have our geometry on ParaView. So we can go on the tab, select P, launch the simulation, and we can see the flow around our object created in CAD. So our study is finished. Thank you for watching, and I hope you have understand all of the parts. Bye.